You should do the decimals. You should. I know. Okay, the length of time worked at a company is normally distributed, with the average length of time being 11.2 years and a standard deviation of 2.1 years. We are laying off, due to cutbacks, we're going to lay off the bottom 10%. Yep. The bottom 10% are going to be laid off. So I'd like to know that cutoff for years. How many years did you work here and get laid off? So find the years worked and still laid off. Okay, I think the picture is helpful on this. Obviously, it's the normal curve. Okay, the bottom 10% are laid off. What is this 10% telling me? How do I represent that in my picture? The area. It's the bottom 10% that's shaded. So I'm just going to say the bottom. Anybody in that part of the graph is going to get laid off. That's 10%, or it's 0.1000 if you went on 4 places, but 10% is back, so I could have said 0.1. I want to know this X value. I don't know what that is, but that's what our goal is. Find that X value. Okay. If I know area, what function on the calculator can I use to find something about this? What is IMSNORM going to kick back? It's going to kick back the z-score. So if I use IMSNORM, what does IMSNORM want to be fed? Which area?
I'm guessing the point.
It's to the left. I need area left of my z. Let area left. Do I know the area to the left of what I want to find? Yeah, it was the number they gave me. Is it always the number they give me? No. So we're going to do IMSNORM of 0.10 or 0.1. This will kick back a z-score. Negative 1.28. So a little over 1 standard deviation below the mean. So if I got the z-score of negative 1.28, how do I kick that back into an x value?
Negative 1.28 equals...
Yeah, we've got that z equals formula. We're working that one backwards. I gave it to you rearranged yesterday, or 2 days ago. No, yeah, it was 2 days ago. Oh no. Oh yeah. I don't have it.
Oh, yeah.
But it's this score rearranged. Do you remember this? So we're going to multiply by the standard deviation and then add on the mean. So that formula works backwards. I'll write it down again. Z-score times standard deviation plus the mean. So our x value here would be negative 1.28 times the standard deviation of, where was it, 2.1 plus the mean of 11.2. So how many years did you work there and still get laid off, or what's the border there? Cut off. What'd you get, Lydia?
8.51.
8.51 years, 8.5 years laid off. All right, one more.
Go on, then we're doing it.
Yep, this is it. Okay, we are going to look at, or if you go to, because this is a college textbook and they're looking at going to grad school, you know how if you go to college you got to take the ACT here? So there's the ACT and there's the SAT, depending on which region of the country you live in. So those are your college entrance tests. Well, when you go to grad school, if you go to grad school, there's two tests there. They're called the GRE, the Graduate Record Exam, and the MAT, the Miller Analogy Test, to get into grad school. So this is a problem that's dealing with those two tests. The GRE, the scores obviously are normally distributed. I'm going to quit writing that. But the GRE, the average score is 1,500 with a standard deviation of 300. The MAT, Miller Analogy Test, the average score is 50 and the standard deviation is 5. So you can see it's just like the SAT. Have you heard about the SAT before? It's like the average is in the thousands. For the ACT, the high score is 36, so they don't even compare in terms of points. Okay, you don't know which grad school you're going, which part of the country, so you take both tests. Your scores. The GRE, you managed to get a 1775. The MAT, you got a 54. My question is, first question, is which did you score better on? Why?
The amount of the average deviation, like a higher ratio.
You're right. You're seeing it right. So you're looking at how many standard deviations above the mean?
Right.
And how many this one was, you can see is
4/5 of what
Yeah.
the
a little less than 1, and this one is
75.
300, so he's looking at the right thing. What are we going to have to do to compare these? Because I can't compare them directly, the 17 and 50, that doesn't make any sense to compare them. You're going to compare their z-scores, because if you turn everything into z-scores, that tells you how many standard deviations above that particular mean you are, the farther out on the normal curve, because they're both normally distributed. So if I convert them both to z-scores, like we'll start with this one, the 1,500, and you got a 1775, let's see what z-score that is versus both normal, 50, and then you got a 54. Let's see what the z-score for each one is. What was the GRE z-score? Was it 0.17? No. 917. And the 54 z-score? 0.8. Well, this one's 0.917 z-score, this one's 0.8 z-score. So was Sam's logic correct?
Yeah.
Absolutely. He didn't even guess. He knew exactly what he was doing there. So, the GRE was the better z-score. Nope. Gotta do an image norm. This is it.
How much more now? Look at it.
This is it.
At least I admit it.
Find the 90th percentile score for each test. Okay, what does it mean to be the 90th percentile? Top 10%. Well, how does that apply to my graph? Top 10% area. The 90th percentile is separating the top 10% from the bottom 90%. So I actually know both areas. Does that make sense? That's what that score is. I need the score here. I've got I'll just do the 1500 one. Maybe we'll do one of them. 1500. So I know areas, I don't know the X or the Z. What do I use? If I know areas, IM's norm. If you know areas and not the Z's, you go to IM's norm. What do you want to feed the IM's norm on this problem? Is it the 0.1 or is it the 0.9? Or does it matter? 0.9. Always the area to the left it wants to be fed. So put in the 0.9. What is that Z score? 1.28? That's the Z score. How do I turn that back into a test score? I want an X value. We just did it in the last problem before this one. Z score times standard deviation plus mean. So Z score is 1.28. Standard deviation for I'm doing the GRE is 300 plus the 1500. So if you know areas, you're using IM's norm. If you know Z scores and looking for areas, use your NCDF. Okay, that's all I got. 1 second. Write the homework down. 5-3.
Oh, 1884.
Didn't do that, okay.
Thank you.
I know, I put it in that car. Why did I put it in K? She's got it. She'll get it. One last night. Is your sorry? I thought I was tired, and then my phone vibrated on my face and scared.
Okay, there you go.
Why did you put pictures?
I don't